and was amazed at his knowledge of soil micro plant interactions. And since that time, I have utilized some of the products offered by Summit Gold and have found them to be of exceptional quality. And more than that, the most important thing to me is the support they offer is truly extraordinary. Not only do they have Dan Coffin, who's a certified professional agronomist who holds a Master of Science degree in agronomy from Purdue. They also have Jared Fry, who has a Master's of Science in soil science. And these guys really know their field, no pun intended. And I deeply appreciate you for taking the time to listen to what they have to offer in terms of what might well be described as a holistic approach to long-term sustainable crop production. And so without further ado, I will turn this meeting over to Jared Fry and to Dan Coffin.
All right. Thank you, Bruce. Welcome, guys that are here. Appreciate you joining in today. My name is Jared Fry. I'm one of the owners of Summit Gold. My brother is involved with it. Our dad originally started it in the 1980s, really. And we're still at it today. It's expanded a little bit since then. Yeah, we really appreciate you guys joining us, hearing more about what we do in our approach to fertility inputs, nutritional inputs into commercial crop production. Yeah, a little bit about ourselves. Again, as I mentioned, we're family owned, operated, started in the 1980s. And over time, more and more folks have joined us. More and more families have joined us to work with us. And we started off, much smaller scale, obviously, back when in the early days, and of just buying and reselling materials to now we do full scale production, blending, and consulting on crops all over the country. And Dan Coffin, who's with us today, you see him here on the screen. He's been with us for a long time, since early 90s, I believe, when he started working, when it was really just our dad and he's been consulting with us ever since and helping us adapt our product line over the years as it's grown and matured onto crops and crop systems and operations all over the country. We work on things from really in all four corners of the country and everywhere in between. Everything from specialty crops, vegetables, tree crops, a lot of corn and soybeans, small grains. Potatoes are a big realm for us as well, and that's being done mostly in Colorado and now a few other pockets throughout the country where those are predominantly grown. So we're really fortunate. We're really blessed to be able to see a lot of different crop types and see and actually adapt our products to crops all over the country. And I think that experience allows us to really see things that work and that don't work, and allows us to translate those onto other areas and other operations, whether they're corn and soybean farmers in Kentucky, as this group is, or guys in the northern plains, or salty soils out in the western part of the country. We can really take a lot of these things that we see and find the best fits and make those available to folks in other areas of the country where it makes sense. So it's a little bit about who we are. Dan Coffin, he's a certified professional agronomist. He joins us from Fort Wayne, Indiana. He consults with us to do a lot of our agronomic training, as what we're doing today, and also in product development and adaptation of our product line, and application of our product line into crop systems all over the place. So he has a lot of experience, a lot of knowledge. You're going to hear from him here shortly. A lot of good information that we hope you'll be able to take and use and make some decisions going forward. And it might change your view on some things and how you view your production of your crops. And I guess the last thing I want to leave you with was that one of the first slides you'll see here that Dan will talk about is our approach, our philosophy to growing crops. And really the keystone of that is that the soil feeds the plant. As we all know, you plant your crops into soil and there's nutrition and there's biology there that's going to help your crop grow. But what we don't often hear is that the plant feeds the soil in return. And Dan's going to talk a lot about what that means. But that is kind of a linchpin of how we view this system and why we use a lot of the crop inputs, fertility inputs rather, that we do, because we're trying to make that system more efficient. We're trying to make that whole system, that back and forth between the soil and the plant, work even better in these monoculture environments that we grow in today. Just a logistical thing. Bruce Sullivan. If you have any questions, please contact him during the meeting, or there is a chat feature. You can actually type into the chat box if you have a question. And if Dan gets that via the chat feature, we can do that in the middle of it or hold those till the end as well. But if you can't find the chat feature, just text or call Bruce, since you guys all know him, and he will gather those questions up, and we'll bring him back on at the end to relay those to Dan. So I think that will do it. Dan, I'll go ahead and turn it over to you at this point.
Hey, Jared, thanks very much. I'm glad to have all you folks stopping in today for a nice cold wintry afternoon to do a little homework. And we dare not forget, Jared mentioned all the places we work, but we dare not forget the thousands of acres of pecan trees and sod that we do down in the Southeast. Because if you recognize, as Jared mentioned, some of the things that we're doing on all these different crops, one of the common things we have people tell us is, well, that might work on your soil over there, but my soil over here is entirely different. That might work on a row crop, but that's not going to work on a tree crop. That might work here, but it's not going to work on sod because you need a whole lot more. The most important and enjoyable thing about this is that soils are different from place to place, but soils have a lot of consistency and a lot of common things that they do. And if you understand that all this, again, goes back to balance, and if you're growing a crop in a soil, specifically a crop is designed to feed a soil so that it feeds itself. And I think that's hard for people to grasp. They're thinking that because we've always bought fertilizer and thrown it in here, we're responsible for feeding that crop. And you're going to learn a few things in here today, I think, that will challenge that thought process. And hopefully you'll enjoy this. And again, as Jared said, learn a few things, because even as we look to the organic growers, people that are doing regenerative ag, all of these people are starting to use the host of all these different products because they're realizing, wow, there is a difference between nutrients and food, and there is a difference in a soil that's actually being fed and nurtured and made healthy, which you've heard a lot about. I know if you're doing anything at all with your local support groups and even the government groups, the Soil and Water and NRCS, they're telling you about this. They're not describing it maybe as well as we'd like to hear, but they are getting closer to helping people understand exactly what's going on. So hopefully when we get through this today, you'll have a little better feel for it. Again, my background is I've been an agronomist, certified professional agronomist since about 1991. So, 32 years now. And I have worked in this crop all my life. This will be, I started detasseling corn when I was 11. So this will be my 52nd crop of corn. I've been in corn all my life. And so some of the guys like to call me the corn whisperer, which is a little bit, I think, far gone. But the fun part about it is watching corn and being with corn all our lives. It does show you things, and it does tell you things if you watch close and listen. It will show you things that you may not have seen before. And I think that's important for people to grasp, because once you begin to see some things that are consistent from plant to plant, some of this stuff begins to make some kind of sense as to how we could even sit here and might talk about how an asparagus plant grows relative to some of these corn and soybeans, and how you can even impact those crops in a similar fashion, because they're still plants and they have something to accomplish. So, well, with that quick bit of introduction and all my years of agricultural experience with different companies, we won't go into that. I'll just go into the science and help you begin to see what we're talking about here. So agronomy, the way it is in some cases, because many of us have our whole lives spent with agronomy, and we have an idea that agronomy is in some cases, because I'm an agronomist, people are always throwing soil tests in front of me. Agronomy is the interpretation of a soil test and tell you how much NP and K to use. No, that's only one small aspect of agronomy. Agronomy has an entirely different point of view. If you're studying the sciences of agronomy, because it brings in the studies of microbiology, soil microbiology, plant physiology, just a whole host of entomology, botany and plant pathology. It brings in a whole host of things that we have to understand. That is the big picture of what agronomy really is. And crop nutrition, the way it should be, is not necessarily a given thing that sets in a box. But if you understand what nutrition is and how it functions, then some of this stuff is going to immediately begin to make sense to you. You're going to see things today that you may have never seen before, and may think there's no way to ever understand it. And it may be just so obvious to you. I mean, I've had people come in here and say, I've heard things my entire life that didn't make any sense to me, I thought. And I figured this would make no sense whatsoever. And this makes more sense than anything I've ever seen. You just don't know where people are coming from and what they've been told and what they think they've seen and understand. And that's the exciting part about doing this all over the country, is we meet people at all different levels. And the reason I'm saying this is unique is because agronomy is really the study of soil and plants and how they interact to optimize production. That's what agronomy is. And so when you understand that, it's like, okay, then what is it that makes soil work? What is it that makes plants work? How do plants function under stress? How do plants function when everything's good? How do plants function under high sunlight or low sunlight? How do they function under lots of rain or no rain? There's a lot of different things that go into that. So understanding that, that's a far cry from trying to take a piece of paper or a whiteboard on a wall and put numbers on it and make plants do what you want to do based on all those numbers specifically, time and time again. It does not work that way. All you can do is hope to get close, manage the closest in the balance of nutrition, and let nature take its course. So if we actually were to put a picture to it, this is what Jared was referring to. This is one of the ways I always start out, because if you don't understand this, then the rest of this is not going to be clear to you, or it may be something that you're going to want to fight hard in your own mind. But if we understand the plant's designed to feed the soil because we put nutrients and things there, we get that because plants anchor themselves in soil. So a lot of that nutrition's got to come from that soil system. We get that. And the hard part is we can't separate the fact that whatever we can buy is going to make things absolutely much, much, much better. It's all dependent on what we buy, how much we buy, and how we apply it. What they're not told is the soil is designed to feed the plant in return. Because if you understand that the plant needs its nutrients, it can convert sunlight into carbon dioxide or with carbon dioxide and water into sugar. But it can't get all the nutrients it needs on its own. It's got to get the nutrients from the soil. The soil itself cannot feed itself energy. It cannot just pull energy out of the sky anywhere. The plants have to deposit sugars, amino acids, small proteins, peptides, peptones. Microbes are in the soil. Bacteria, fungi, protozoa, all kinds of different things. These mycorrhizal fungi things and all the stuff we hear talked about. All that's in the soil, but it has to get fed by the plant. It can't feed itself. So anything that dies and lays on the surface, it can eat, break down. Anything that's living in there that can deposit carbon in the soil, it's going to live and do well on. So if you understand that, you'll see that plants and soils are supposed to work in sync with each other and replenish each other's needs all the time. A soil that has no plants growing on it, none at all, barren, eventually is going to go completely dormant and or die over time because it has no way to feed itself. If you see the world like this, then a lot of the questions that you may have raised about crops you've grown through the years and farming can be answered. If you don't, if you miss it, you'll always have more questions than answers because you're going to be looking for something else that you think is over here getting your attention, and it may have absolutely nothing to do with the way that season went down and why that crop performed the way it did. So this is going to be a little bit of our approach and how we do things. And obviously, we put seeds or plants in the ground, depending on whether you're growing, a seeded crop or a planted crop, stuff from the greenhouse. We're going to start out as a starter. And we talk about starter and on-seed starter blends because there are some things that are absolutely critical to starting any and every plant off. And we find that one of the most consistent things we've done through the years is create outstanding starters. One of the things, if you guys are doing anything at all with the Dowdy Hula Group or Kevin Kalb or any of the other groups, you're going to find out, you've heard, uniformity is critical. Just getting the planter in some cases to do a better uniform job will dramatically increase your yield with or without some of these things. But it's not mutually exclusive. But a field that's very, very ununiform is always going to have trouble being a maximum performer. But if you get uniformity across the board with nutrition and stand and growing simultaneously, you always know those fields are going to be a winner unless something goes really bad in the weather in the middle of the season. So we start with starters. What aspects of starter fertilizer matter? The phosphate. You buy starter for phosphate. You can say I'm buying a 318-18 for potash, or I'm buying a 918-9 for more nitrogen. All that. All those have some value, but nothing has more value in a starter on seed, or even in some cases in a 2x2, than the phosphate. Because phosphate and its availability to a plant is what allows the energy conversion, storage, and recycling of energy to make it possible. So phosphate is critical. Cool soils suppress the natural release of phosphate. Those of you who have tried starters over the years, and let's say you get off to a really good start year in and year out with warm seasons in the spring, nice warm temperatures, happy, healthy soils with 65-degree temperatures and good biology, you don't need orthophosphates as much in your starter. And that's why a lot of people have been over time, and they don't know why. But cool soils that suppress the natural biological growth of soil itself will not release phosphate until they warm up. If you're in those situations and you're buying a starter and you want to plant early and you want to get things done, you have to have orthophosphate, the available form, in your starter. Polyphosphate is what a big part of 1034O is. So it might be a maximum of 30% orthophosphate and 70% poly. That poly's got to continue to break its chains apart and become available. So if cool, wet soils prevail, they're not going to change. So really, 1034O is not supposed to be treated as a starter. Sure, you can put it in the 2x2, but if you put 1034O on a seed, if you get a good, quick, warm start, you'd be fine. If you have an extended cold start, you're going to hurt. There's other things going to happen as a result of putting on the 1034O that you don't want. Phosphate fertilizers can have a wide range of availability. They can be 30-70s, they could be 90-10s, they can be 50-50s. We have found that over time, the most economical purchase that you can make is something like an 80% ortho, 20% poly. There are a number of good 50-50s that are starting to show up on the market that are low salt, and those can still have value too. But the best single value for the maximum amount of orthophosphate and consistency has come from an 80-20, roughly an 80-20 blend of orthophosphate 80%, polyphosphate 20%. You want low salt, and if you can get it, you want a moderated or a slightly alkaline, a slightly acidic pH, 624.6 or 725.5 that we sell at SummitGold has a slightly acidic pH, because oftentimes when you're buying 918.9s or 318.18s, the pH is maybe way up in the 8s, and you don't get burn necessarily from them. From the salt, you get burn from liberating free ammonia in the furrow, which if you have a high pH already in your soil and you use a high pH system, the microbes can't find any acid. They start cabbaging off hydrogen ions, which are really acid ions, off of the ammonium nitrogen, and they turn it into ammonia. And if you have ammonia in the furrow, that's a volatile product and it's going to give you burn. So buying something like a 725.5 with an acidified pH, you get rid of low salt problems. I mean, you have low salt, so you get rid of high salt problems, have low salt, and you have lower pHs, and it makes it that much safer. Helping or hurting the microbiology in the root zone. Well, obviously, living things and salts in high concentrations don't get along. So if you're using high salt fertilizers and you're damaging microbiology development, it's one of the things that people make the fight about with anhydrous ammonia. Anhydrous ammonia can be extremely high pH, and it can be extremely salty, and it's extremely desiccating. So it has an impact. I don't throw away the baby with the bathwater. If you want to use anhydrous ammonia, if you keep your application somewhere around 80 to 100 pounds of actual nitrogen, and you're putting it out in the field early, and even some cases, some guys even plant over it the next day or 2 or 3 days later, or sometimes even the same day. You keep those levels down, it's not a problem. You can still use it. Most guys just don't like it because it's not safe. But the whole point is, if you damage microbiology for an extended period of time, then they're not working for you, and you'll find out here why that's important in a few minutes. Also, the effect on the soil pH, acid forming versus alkaline. If you have products that have, let's say, sulfur in them, sulfates and sulfur, those are what we call acid forming products. And when you make acids in the soil, you release other nutrition. You release manganese, you release iron, you release copper, you release zinc, the metals. If you take metals and put acid on them, they melt. And when they melt, they're available. So we use different forms of fertilizers, potassium thiosulfate, ammonium thiosulfate, ammonium sulfate in and of itself, different sulfates that form acid, and as a result release phosphate. They release a lot of other nutrients and elements. So it's a part of our approach that we use. And oftentimes people are like, well, why are we using so much sulfates? Well, it's because the sulfates actually are good for the soil. They feed the soil and the plant, and they make other nutrients available. So those acid bands will release more nutrition all around them. It's like using chemistry as your friend. You know, when you take calcium and phosphate and put them together, well, we call that cottage cheese indirectly in our business. It forms an insoluble material. But when we use acid chemistry to put into the soil, it acidifies all around the band where we've put it, and we release all those elements I just talked about. So even though we don't necessarily understand it completely, when we use these fertilizers, they're making more fertility available from the soil for us just by purchasing them. So if somebody said, well, ammonium thiosulfate, that's the most expensive nitrogen I can buy. No, it's one of the cheaper ones you can buy, because if it was just nitrogen, yes, it would be one of the most expensive. But because it has sulfur, which will help you fill ear tips, especially forming the ear tips when it's real small, and it will release all these other nutrients simultaneously, it's actually, as a big picture, it's one of the most inexpensive products you can buy. Past over application of dry phosphates, it can always also be a problem and cause nutritional tie-up. If you think about what I just said, if calcium and phosphate, when they find each other, they lock up and they form this, basically they form teeth and bones. It's called, it's a mineral that we call apatite, technically, but it's teeth and bones. That's what we have in our bodies. If we put too much phosphate fertilizer on, or we have too much liming that's going on simultaneously, it can actually make our phosphates disappear. Now, they're not gone. They just disappear from the soil test because it's sitting there in the soil as calcium phosphate. And guess what breaks down calcium phosphate? Natural biological systems. And so we can tie up too much calcium if we get too much phosphate. We can tie up too much zinc if we get too much phosphate. If we get high levels of zinc and no phosphate, we might have zinc toxicity. There's all kinds of things that go on in this. We don't practice as farmers trying to be told to understand this. But as we begin to look at some of these really high yielding situations, when we start realizing that these connections are out here, and we start breaking apart some of these connections and making stuff free up and release, it's like, wow, what's happening to my productivity? The other part that people don't understand, especially about corn, it's not as critical on soybeans, but definitely on corn. When you have a corn plant that's basically, here you see the seed has germinated, you've got the radicle and the seminal roots, that's the first roots you see. You've got the crown, which the nodal roots start to form from. This is a plant that basically would qualify as almost a two-leaf plant. Once that second leaf up there, now the first leaf is the emergence leaf. I don't count that in my world of agronomy. That's VE, that's V emergence. The first leaf, and it's falling over 50%. It's actually a true V1 plant. It's almost a V2 plant when the second leaf does it. So it shows 3 or 4 leaves, but this is not a V3 plant. This is barely not quite yet a V2 plant. By the time this plant gets to 3 true leaves, so the one in the middle comes out, bends over about 50% of its distance, that plant's already determined its rows around. All grasses do the same thing. Absolutely all grasses do the same thing. They set their yield potential early in the first 30 active heat accumulating days. Wheat, barley, sorghum, corn, all of these do the same thing. We've seen this even through people doing electron micrograph studies. We know that that's the case. By the time this plant is 5 true leaves, it's already determined the length it's going to have for an ear. And we've done this. People have fought with me for years on this, but we see years when we get darkness or we get herbicide injury and all kinds of other stuff. By V5, 5 true leaves, the ear length has already been determined. So if you understand that, and this root system that's down here coming out of the seed is responsible for taking that plant through 5 true leaves. If you understand that, it's why starters even work. There are so many things that are excluded from that young seed root that when that happens, that's when things go wrong. It's also to make things go really right. And when you need things like boron to set the maximum number of kernels, sulfur as a sulfate form to make sure that the zine protein can actually be formed so that every kernel that's programmed can be turned on to actually grow and pollinate. If you're a situation where you have ears of corn and you've got a tiny, soft, fluffy tip that comes to a point on the end, not a rough, cobbed up one, a little soft, fluffy tip, and you see where kernels are supposed to be, but there's nothing there, that's a sulfur deficiency when a corn plant is this tall. And you can actually grow more corn just by getting the sulfur levels up to make sure that you don't have sulfur deficiency. So there's so much that goes on behind the scenes, all of this qualifying as agronomy, that we say people in some cases, they just get flabbergasted, like, oh, it's way too much information. But if you're a guy that, for years you tried something on the seed and something didn't work, so you switched to the 2x2. Then you went to the 2x2 and you shut the furrow off. So you tried things in 2x2 and things didn't work, or maybe so much, but you didn't get a lot of improvements. And maybe you were doing things on the surface with different combinations. The hard part is understanding that if you used all three simultaneously, this is one of the reasons why these systems work, and they develop more uniformity and more consistency, and they've been used now in some cases for farms for decades. Because if you set this thing up right, there's very few things that can go really, really wrong. It's not that everything goes perfectly right. It's just that things don't fall out of bed and they don't go really, really wrong anymore. And I think that's what people need to understand. Why is the phosphorus so critical? Again, a while ago, you heard me say that a plant that's an energy conversion machine has to manage that energy. That energy is managed early by phosphate. And the more total orthophosphate you get in a plant, the higher the sugar levels are. The higher the sugar levels are maintained, the higher the stress tolerance is. And based on research done at the University of Guelph over in Canada, where when they were farming on all these heavy blue clays on the other side of Lake Erie, they couldn't get phosphorus any way or form to do anything for them until they finally went to on-seed starters with orthophosphate. Once they did a magnificent study that helped us all understand that the higher the orthophosphate content is by V3, the more kernels you put on a plant. So where they had high levels of orthophosphate early, and this is a very complicated, I shouldn't say it's a very complicated study, it's just intact, a lot of information. What they did was they kept cutting the available phosphorus on the early side and then kept the late available orthophosphate high. Every time they cut the orthophosphate availability, they lost more and more and more kernels. So the lesson, which is always what we've told people, is by the time that plant is 3 true leaves tall, and this was a study that was done in Canada, so the 3 leaves you just saw a while ago was a true V3 plant for them. For us, it's not. But by V3, if you don't have enough orthophosphate, you don't set more kernels. So that's why starter programs with high orthophosphate content works. It's because that plant sees lots of energy, it has lots of sugar, it has lots of programming capability, and it puts on more and more kernels as a result. So, nutrient transitions. Just because nutrients may be in the soil does not mean they're available. And we've seen this for years. We know that the phosphorus that you measure when you get a soil test is a small pittance of what's really in there. Because some of it's tied up with calcium, some of it's tied up with zinc, some of it's tied up with manganese, some of it's tied up with copper and iron. There's all kinds of phosphorus in there. Microbes are responsible for moving that nutrient level of different phosphates to plant available forms. That is what a lot of them do. A lot of them do this. And so what we've seen is for guys that have gotten involved over the years with more and more microbiology in conjunction with their orthophosphate, they don't carry what they used to carry for soil test levels of orthophosphate. And they're doing marvelously well. In many cases, they're getting better and better all the time on soil test levels of phosphate that would be moderate at best. And they don't get worried about it. They used to. They don't worry about it anymore because they realize that there's probably hundreds, if not thousands of pounds of phosphate in the top 0 to 6 inches if you do the actual complete measurement of phosphate in that soil. And phosphate that gets applied, most of the stuff that we do is 1152O, it's MAP, or it's 1846O, it's DAP, or 1034O. Now, the advantage of 1152O and 1846O is it is 100% orthophosphate. However, once it starts to dissolve and it finds the calcium, it ties up just like everything else does. So the scientists estimated at one point that when DAP is actually melting and the phosphate is available, it's available for a grand total of an average of about 28 minutes. So when we used to use DAP beside the row in a 2x2 planter which was dry, we had available phosphate. If we throw it out on the surface, the chances of that phosphate finding its way directly into our plants this season is pretty slim. And I think people have begun to realize that. That's one reason why they're not using as much dry phosphate and why dry phosphate prices go up and down all the time, because well, we need people to use more, but they seem to fight it. And that's part of the reason why. they're stored in organic matter or mineral forms in the soil. All these different phosphates are. And so, there's a whole lot more behind it. We won't get into that now, but the whole idea is there's a lot of different forms of phosphate, and figuring out ways to make them available are just as productive, in some cases, or more productive than just buying them. 90% of what plants absorb of phosphate must be available by microbes in the soil. And the soil scientists are telling that all the time now. It's like most of it just went through some kind of microbiological development. I'll show you a picture here that will completely show you and help you understand what we're talking about. The observations in the last few years were 1034 sidebands with complement. And complement is our SummitGold product that's the microbe base, the microbiology. Are showing abnormally high and sustained values of tissue level Ps. And I think this is interesting for people, especially if they've been trying to get these phosphate levels up and they can't maintain them. We're going to cover that here shortly. But when you understand that you can buy orthophosphate, or the orthophosphate, the phosphate form that comes out of biological development is the exact same orthophosphate. It doesn't matter. The plant's not going to see any difference one way or the other. So you can either do it microbiologically, you can do it if you want to buy the orthophosphate, you can marry the two together, which is the best of both worlds, especially if you're worried about cool, wet starting conditions. You get this little by little, you understand where it's coming from, you're going to perfectly understand where this thing is headed. And the irony of it is, especially if you've got a dairy farm, the people who started employing this, the energy levels in these plants are so high, what they're finding is their same amount of acres go so much farther because the feed that they're giving to the animals is going so much farther. If they're producing higher tonnages and more of it, their costs of feeding have gone down dramatically, and the animals are doing way, way, way better on these particular forages that they're growing. On the bottom there, an acidic root zone promotes the release of other nutrients. We kind of covered that a little while ago with the acids that are released. But fertilizers and biological products you can use dramatically influence all of this. If you understand that they're built to kind of go together and work with each other, this will really begin to be fun. This goes back more than 30 years, and I've been sharing this for a long, long time. This was right out of when I was in college. I got a master's degree in soils and agronomy, and I taught as a TA a basic soils course, and then as the actual director of the soil fertility lab I taught. So we use the nature and properties of soils to get a lot of information. So this is right out of Brady's book. And this was actually done on corn. And what this is basically showing is a side-by-side where they had no phosphorus in young growing plants compared to 25 parts per million, which would be the equivalent of 50 pounds per acre if it was on a soil test. But this is with and without phosphorus, without and with biology. So the first column, the first two columns there, you see on the first left column, you see all the nutrients: phosphorus, potassium, calcium, magnesium, zinc, copper, manganese, and iron. These are the ones that were measured. No mycorrhiza. So the first column is where no added phosphorus was given to the plants. And it's funny, they found phosphorus, even though they didn't put any phosphorus into the plants and the soil. The plants had phosphorus in them. Well, you hope so, because there are 18 essential elements. They're not suggested, they're essential. So if a seed germinates, it's finding all 18 somehow or another. Even if it's a very small quantity, they're finding it. Well, where we had just sterilized soil with no biology and no phosphorus added, we still managed to get some nutrients. And you can see the numbers listed there. What happens when we inoculate this soil with mycorrhizal fungus or some soil biology? Look how the numbers jump. So we didn't add any phosphorus to the tank. We just put in biology, and bam, just like that, the numbers jump. Now we go to the other side where we actually had some applied phosphorus. And let's just say phosphorus better work, because if it didn't work, then we've been wasting our money all our lives. And in this case, it's pretty obvious. We add a little bit of phosphorus, and lo and behold, the plants find the phosphorus and they jump in their energy levels, and you start to see it. And their root masses get bigger and better, and they start finding nutrients more successfully. So even phosphorus as its own product applied through the years has been successful. It better have been, or you guys who've been listening today wouldn't be listening. It wouldn't have worked, because previous generations, that's all they knew to do. But look what happens when you marry a little bit of phosphorus in the orthophosphate form and marry biology to it. Look what the numbers do. It's not like they doubled. I mean, look at those numbers. And this is what we find people on dairy farms and animal farms, and even just general agronomy all across the board. They tell us that the nutrient density goes through the roof. And this is why. Look at the nutrient density that's gone into these plants. And so this is the exciting part about it, understanding how to utilize these together if we put phosphorus in a band and biology in a band, or biology in both bands, or some biology in one or the other bands and some on the surface, look what can happen to these plants. This is no surprise. This is no scientific surprise. So we put it into action. What kind of things do we do at Summit Gold? Well, we have an on-starter seed blend. This is the most common of all the selections. This is not the only option. There are several different options, but this is the most common, where we would start out with 725-5 at 4 to 5 gallon per acre, which is an 80-20 blend. And it's available the day it's planted in the soil. As the seed's sitting in that, it's seed safe, and it's low salt, and it will germinate, and that orthophosphate is available, and that's what makes roots, that's really what pushes roots to grow and grow fast. It's the right form for early season placement. It's safe, it does everything we need it to do. We would throw in a 0.5 gallon per acre of some SG Assist, which is a load up of carbon units. If you think about carbon as complex sugars and simple sugars and organic acids like humics, fulvic acids, even vinegar is an acetic acid. Those are all organic and different. We call them organic. They're not organically certified. They can be, but in this case, they just have a carbon backbone, so we call that organic. That's an acidic pH for maximum nutrient release. It's got food for the biology and biology that goes in it. So it increases the biological conversion of phosphate, as well as providing for the phosphate that's been put in as a part of the 80-20 blend. We also throw in something called Infuse. Infuse is like one man's idea of putting together many things so I don't have to think about it. We throw in the SG Assist with the micronutrients. It has other protectants, if you will, some other things that we can throw in here to actually protect the seed. Ironically, we don't recognize that when we have microbiology in the furrow, the microbiology actually sends out signals to tell the seed to germinate. And where we actually have started augmenting this biology and bringing the biology levels up in the furrow, the seed is much more faster in germinating and much more consistent. We have seed treatments now that when we put on, it's almost exclusive biology. And when we do that, a lot of the fungicides have disappeared. Because if we get the plants establishing the roots and done it properly and get the nutrient levels up, they don't need all the fungicides in some cases to fight off all the diseases. And we have people now that are just using on-seed starters that are microbiology developed, and they don't worry about some of the other stuff that they have to slap onto these seeds. The thicker and thicker they make these seeds, it takes them days and days to germinate just to get water through the coatings. Where we have naked seed with basic biology on it, sometimes they're out of the ground in 72 hours and they're off to the races. Here's a picture of vegetable crops. I mean, we see pictures all the time, and you guys have. You've either participated and took pictures side by side with corn plants, but realize vegetable plants are just as important, if not more important, to have a bigger root mass. And so the same type of program that we're talking about putting on corn will go on potatoes at 60,000 pounds of potatoes to the acre when it's all said and done. Those root masses are critical to developing the plants and plant sizes and harvesting the nutrients in the soil. So here's a situation side by side where we see this, and we see it in about every single crop. We've even done it in trees, for the guys down in Georgia where they have tree nurseries for pecans. The same thing happens, massive increases in root masses and much faster establishment of these young plants. Let's say I don't have an on-seed starter, or maybe I don't even have a 2x2. Do I have any other options? Sure. We can actually go to systems where you can put in orthophosphate and spray small young plants, or if you just want to do an early broadcast of something like microbiology over the top of the soil, we have a product that's actually a 50-50 blend, SG Accelerate. When we say 50-50, what that means is microbes that release nutrients and microbes that can break down the stalks, work as stubble digesters or stalk digesters. You put it out a quart to the acre. It's living biology along with some food sources, some humics or fulvics or sugars. You have carbon cycling and residue degradation. You have nutrients and nutrition and growth promoting properties. You'll have some of these organisms actually make the plants, they produce root growth hormone, and they will make the plants do better. And so you can do a lot of different things and accomplish the same goals in different ways. Whether it's a 2x2 or a surface application, if you don't have it to be able to go on the seed, it doesn't mean you can't do some of these things. We have ways of helping ensure that we're fighting against some of the extremes of the weather conditions, and you can do them all kinds of ways. And it's going to increase the biological conversion of phosphate at the same time, just like we would do, in the furrow. It won't be quite as fast, But as long as we get the microbes watered down in there, they'll be perfectly fine. What about early nutritional demands of these young plants? Early micronutrient applications on the early side are critical. Why is it so important? Well, micronutrients are specialized building blocks. They enable many things to happen within our bodies and within the plants and small and the microbes, including reproduction. Corn, the most important reproductive processes take place in the first 30 active days of growing, first 30 days of life. It's setting its yield potential, just like young wheat does. Oftentimes, wheat throws people because it's like 1 year, a wheat program that's put on in the fall might produce a 90 or 100 bushel crop, and the next year it makes 30 to 50. And it could be because of late planting. It was planted right before the winter. It only had 1 or 2 leaves. It hasn't set its yield yet. Hasn't had enough energy to do it. So it's going to set it in the spring. So you put all your fertilizer on the fall on a crop that's only this big, and it hasn't set its yield, and then things go wrong in the spring. You're never comparing apples to apples until you actually know what's going on with the wheat growth. So if you're actually able to put out wheat early, if you're going to get wheat out in September or early October, you better get the nutrient load in there because you're going to set the head. So somebody tells you, I'll just put on 10 pounds of nitrogen, we'll do something next spring. Don't listen to that game. And likewise, if you've got it planted late, don't go be putting all the fertilizer on it. It's perfectly fine to set it on late winter, early spring, provided you can get on the field. If you don't understand that, then wheat's always going to be a problem for you. It's never going to be something that you can figure out. Early micronutrients are critical in many other crops too. And I think part of this, if you think about all these different things going on, enzymes have to have certain micronutrients stuck on the end of them. And enzymes are very complicated proteins, but we won't get into that. But the whole point is, if you spend all your energy to make enzymes inside this plant, and you don't have the right micronutrients to stick on the end of the enzyme to make them functional, you wasted massive amounts of time and energy for that plant to do nothing because the enzymes aren't going to work. This is why molybdenum has been focused in on for both corn and soybeans, because of the nitrate reductase enzyme that turns nitrate back into ammonium forms, which will make that plant reproduce better. Nitrate is going to make the plant grow really pretty. It does nothing for yield potential. We'll cover that here in a few minutes. But the lack of micronutrients will diminish reproduction potential. And if you think about a pregnant animal or a human being, they need lots and lots of micronutrients during that gestation period to make sure that young growing fetus and baby are going to be properly growing. It's when things go wrong nutritionally that things start falling apart within the womb. And that's when things can go really, really bad, especially if the genetic potential, has some issue that needs certain micronutrients. It's going to be problematic. Okay, so we covered that Molly thing at the bottom. So let's skip on. Here's a picture. This is the picture of a young corn plant, a crop of corn underneath center pivots. And you can see on the bottom where the micronutrients have been added. This is the new pictures that we get from drones and everything else of plant health. And look at the dramatic improvement in plant health on the side where they put the micronutrients. And this is one of the things they were just searching for, was better early health, larger leaves, better biomass, deeper, thicker color and thicker leaves. All of these things that they wanted, they were able to achieve with putting out early micronutrients. And even something as simple as a drone taking a picture from somewhere up in there can pull it out for you. How do we do this? Well, our early micronutrient applications start with several options. One of them is MicroStart Zinc. That has a heavy micronutrient blend with zinc in it. It's a higher content of zinc, but it also includes manganese, copper, and boron. And it's fully seed safe and fully chelated. Chelated means it's been encompassed by an organic backbone. So if you took calcium and phosphorus completely unabated, just took calcium and phosphorus and put them in a test tube with water, you're going to have a mess. But if you take the calcium and you chelate it around the calcium with this organic backbone so that nothing can touch it, the calcium's inside, you can throw it right into phosphate and nothing happens. That's chelation. It's the Greek word for claw, a claw being around it. It makes it completely utilizable by the plant, but keeps it safe in a chemistry mix. So we take all the nutrients that we have in here and we chelate all of them. We don't want anything with a chance to react in a test tube site situation. Another option is SG Elements, or the balance product that we have, which is a balance of micronutrients for low boron soils. So for instance, in the MicroStart, we might have 4% zinc and 1% manganese and some boron and copper. In balance, we're going to have like 2% manganese and 2% boron with some zinc, copper, 1% zinc and copper and iron and some other things too. Again, fully chelated, a little different balance, because balance itself is probably better on the broadleaves, where microstarch zinc is better on the grasses and some of the vegetables. We also use fulvic acid as a part of the system for energy, but we also use it as an extension of cation exchange capacity, because when we put fulvic acid into soils or into starters, it also provides some extra exchange capacity. So as micronutrients are being made available by some microbes, we actually have some extra places to store them. So we can keep nutrition higher in the furrow around where the roots are. So there's a whole lot of other things that go on here. Plus, all that extra carbon or energy from these organic acids is a crop and microbial food source. Food is different than nutrients. Don't get them confused. We'll cover a little bit of that here in a few minutes. How about sustaining this nutrition? One of the things you need to know about modern science is it's allowing us to be able to understand the microbes. And one microbe does not necessarily do one job. It does many jobs. But we are also able to run these things through testing methods to help us understand what certain microbes and their genetic potential are allowing them to do. This allows you to look at this. And so when you look at some of the things across the top here, the different things that can be done: protein release, starch release, same thing here, lipase, starch. That's supposed to say phosphate. I don't know, I've seen that for years and didn't realize it was an error. Phosphate release, IAA, which is the root growth promoting compounds. Lignin and cellulose, if there was potential to break down lignin or cellulose. Chitin, which is the outside of the insects, the nose on a nematode, different things that are chitin based. Nitrogen, iron is siderophores, ammonia. All of these things can be characterized. And you look down at the bottom here, the group in complement has all of these things that it can do. It's fascinating stuff. When you realize we know a lot about microbes that we didn't know even 20 years ago, a lot more in just the last 5 to 10 years. And when we put these combinations together, the way we figure out that they're in there is we look into the plants and see if some of these things are being done. And lo and behold, you can figure out that they're there. You can look at their genetics and pull them out of the liquids. Not all of them sometimes, because they're pretty close. But the fact of the matter is, we know these things. So if we know these things and we've built teams of organisms out of this, there's a lot of predictability and repeatability that comes as a result of using these things. So in products, back up here. Whoops. Sorry about that. Hit the wrong button. We can go to Originate, which is a seed treatment that has all the same biology that you just saw with some of the things. SG Assist, which has energy in different forms as well as that biology in it. Complement, which is just the organisms by itself, if that's what you want to buy and try. Or SG Infuse, which has everything that we talked about before, along with the biology. You can buy different portions if you're familiar with or want to do certain things or want to run certain tests. You can buy biology, any one of these 4 or 5 products. And it's nice because now what you're looking at is nutrients and maybe energy in conjunction with a little seed protection and further nutrient release as a result of what's going on. This is a comparison that was done with tissue testing a couple years ago, where we're looking at comparing one biological product with 1 or 2 organisms in it. That's very common out here, very common nitrogen releasing product. So it focuses in on mainly nitrogen. That's what it does. And here, when we put this stuff side by side, these are 2 separate hybrids. The two lines on top are one, the 7876, the 6617 on the bottom. The ones that are in yellow are showing you where you're significantly higher in the nutrient over just the nitrogen manufacturing compound. Now that hopefully should make some sense to you, that if it's just focusing in on nitrogen, that's what it's going to deliver. When you focus in on the other nutrients or the other microbes that release the other nutrients, you get a whole lot more. The sad thing is the nitrogen compound product is significantly higher in cost for one nutrient. You buy this one, it's significantly less, and look at all the advantages that you get. When people have started working, especially in the vegetable industry for years, the tree industry, and now even in the corn industry, and they're trying to keep their phosphate levels up in the tissues, they're trying dry fertilizer. They're trying 10-30-40. They're trying all kinds of ways to make it happen. And they've dealt with frustration after frustration for years. Well, ironically, as we started doing this in the last few years, and people are comparing it very well, where we put orthophosphate in the furrow, and we put biology in the furrow and or in the 2x2 or on the surface, or make multiple applications of really, really low rates. You don't have to use high rates during the season. This is what happened with potatoes, which are critical at petiole, what they call petiole, or the big leaves, when the potatoes are starting to set. When that energy is going to those potatoes, they can't keep the soil or the tissue levels of the phosphorus up long enough. The petioles start to fall. But when they went to putting orthophosphate in the furrow, a little orthophosphate through the center pivot, and a little microbes through the center pivot, look what happened. All of a sudden, those phosphorus levels started to hold throughout the season. And some guys saw as much as 15 to 25% increase in the number of potatoes they got, because the petioles finally stayed up. For those guys there, you're listening from Kentucky, I've had guys in Kentucky had this same problem, big farms in Kentucky that were trying everything known to man to try to keep the phosphate levels up. When they finally went to higher levels of orthophosphate, let's say 4 or 5 or 6 gallon on the seed, and they put in the biology, lo and behold, phosphate levels stayed up and the yields went up. It's no surprise, because they're supposed to work that way. The soil is supposed to work in conjunction with some of the nutrients in the plants, and when they do it properly, it's no surprise that these things start to happen. How? I saw this picture years ago. I saw the guy that produced it, because it was in the laboratory where we were working on some of this biology, and he passed by this thing like it was no big deal. I said, back that up. I said, buddy, that's $1 million picture. This is genetically controlled Arabidopsis. It has the genetic feature that it says it won't make hair roots. Well, when we actually put the microbes in Petri dishes, where on the left it would not make hair roots because it was genetically controlled not to, that's the same exact stuff that we have on the right side, except the microbes are in that Petri dish. Like the microbe stepped in and says, not in our world. We grow plants here. We take care of plants. You give us the roots we want. We're taking care of you. So as a result, I tell people, well, what happens if you had 2 or 3 or 4 times the root mass? Well, people would commonsensically say, the one on the right is obviously going to do harvest better. It's going to give you way, way more surface area. Phosphate comes from very, very tiny places and from microbes. Well, if the plant is giving off the food sources to feed the soil, and they're coming out all the surface area, what do you think is going to happen to the microbial development around those roots? It's going to go through the roof. And if they're designed to release phosphate, lo and behold, you're going to find way, way, way more nutrition. That's what I asked him. I said, let me ask you, which one of these 2 plants do you think is going to have more total net nutrition in it, and isn't going to have to work nearly as hard? It's not a trick question. It's pretty obvious. And so if I can make this repeatable year in and year out with the stuff that I do on your seed, in the furrow, on the surface, balanced out, these plants aren't working nearly as hard to make the yields that we were trying to get them to accomplish. Now, if we're spending all kinds of money on just dry P and K and nitrogen, and we're not meeting the micronutrient needs, all the extra N, P, and K you put in here, if you don't meet the micronutrient needs, right, isn't going to give you anything. It might get lucky in a year where the rain is good and you're getting a little extra organic nitrogen, and you might top out, do a little bit better. But if you don't get the micronutrients right from the start and get the levels up in the plant, the macronutrients don't get to do anything more beyond a certain level. So you might be stuck at a 260 bushel high-end yield average, and you're trying to get to 300. Well, you're never going to get to 300 unless you get the micronutrients straightened out. And I think that's what we're looking at. Or if you put more plants out there, and you can take the stand population, and you're not the population dynamics aren't gone over too high, then you have a chance to make more. But you're not going to do it consistently, even at the same stand, unless you get those micronutrients balanced out right. So nutrient availability goes up, uptake efficiency goes up, phosphate levels, 10 times more sites on all these little roots to absorb orthophosphate in the biological or the orthophosphate form than any other element. 10 times more. That's how important phosphorus is to a young plant of any kind. Understand that. It makes perfect sense why some of these systems are being employed and being employed properly, and they're being used more consistently, because it's scientifically programmed into these things to absorb that. More space for the microbe to release more total net nutrition, and the more diverse the population of biology is, the more chances you're going to have at getting all of these elements released for you. If you really want to try a unique thing, go out and get some of your actual native soil in a woods and put it in the furrow or along the furrow or the top of the furrow around a few plants and watch them and see if they don't develop better, because the native biology that's there is already used to the soils and some of the things it's doing, and it releases a lot of that. So, you know, we have a lot of people saying, well, why don't you use my soil? Well, we could, but, you know, all these microbes we put in here are all soil derived. They're all common. They don't have to be genetically modified. And there may be a few more microbes, obviously, that we can put in here. But the reality of it is, it's doing a very, very good, consistent job, because if we put microbes with every seed, because there are certain microbes in here that I guarantee you have in your field, but you have no idea where they're at. You have no idea what populations they are. We put them in here in very high counts, so that as you plant and put a little in there every single year, you put it with every single plant and it develops the uniformity. That's what this whole high yield thing is all about, is uniformity. So we can release more locked up fertilizer and make that plant do well. This is why 7-25-5 and complement organisms work together. Let's say you can't do this, you want to go back to the 50-50 blend. Here is another testing array, the same thing you saw before with complement. This is SG Accelerate, which is the stubble digester. So now you marry in stubble digestion along with all these other releasing things. When you break down the stubble, you release carbon dioxide up into the canopy. When you do that, the plant finds more carbon dioxide. And for those of you who can remember third grade science, carbon dioxide plus water in the presence of plants with leaves harvesting sunlight makes glucose sugar and releases oxygen to the world. That process is called photosynthesis. So in that sense, what you can do is, if you marry the 50-50 blend, marry them together, and you sprayed it on the surface where there was stubble or even lignin and cellulose, which is still in your organic matter that hasn't broke down, you release carbon dioxide up into the system. And when that carbon dioxide gets up into the canopy, it causes the plants to yield higher. Don't get worried about carbon dioxide and carbon credits and all the other stuff. If we had another hour and a half, I'd show you exactly why that's a hoax. Don't worry about that. The better thing of understanding is, if I have a canopy of plants growing and I release carbon dioxide in it, it isn't even going to get hardly to the atmosphere. It's going to go into the plants, and we're going to get more out of that. It's fun when you understand what the science really is. And this is an opportunity to enjoy that. Now, what about other things? What about later on the season, or let's say early season, we're getting damage in our plants, you know, especially with soybeans and list and dicamba beans and or herbicides that are too hot, applications of accidental stuff. Recovery after crop injury or stress and early foliar opportunities go hand in hand. Crop energy, you know, you don't like what you see, especially if you're looking at something. Now, if it's just plants that aren't growing and maybe a little off color and I don't understand it, I don't like that either. Well, what am I really seeing? What is it showing me? I see something damaged, but I want to know what it is. Well, certain vital systems in the crop are being disrupted. And it's primarily due to the inability to make its sugars, its amino acids, and its proteins. And when it stops doing that, it gets scared and it won't do anything. It won't grow roots because it's afraid if it spends energy, it's going to die. It won't grow tops because if it doesn't have roots underneath it, it's afraid it's going to grow tops and no roots, and then it's going to die. It's in a funk. You got to break that funk. And what's going on is, if it's been told not to make amino acids by a herbicide, it isn't killing it, but it's not working right. Amino acids are needed to make proteins, and proteins are needed to make enzymes. If it's not doing its job about harvesting sunlight and making carbohydrates or sugars, it has no fuel to run the machine. What do? Well, you know, it's sad, but it's this simple. If it can't make it, you give it to it. So you come up with something that has sugars or amino acids and or proteins in it, so that it can jumpstart its motor and say, hey, I don't know what happened, but I just got stuff delivered to me. Just like that, all of a sudden, certain systems kick in and the plant's back to growing. If you have beans that set still for 3 weeks in the spring because it's got a snoot full of too much pre-emergence herbicide, it's gone down in the roots and shuts it down, and they set still for 3 weeks, they're already such poor conversions of sunlight, converters compared to corn, you're going to lose 20 bushels, 25 bushels. And I have people all the time, they're like, I don't know what happened to these fields, but you know, we put a little too much authority or something like that, Zidua or Sharpen, and we got a heavy deluge of rain, and it was being set still for 3 weeks, and they were 25 bushels behind. Yeah, that's exactly what happens. And so all you got to do is find something that has those 2 or 3 things in it that's absorbed right into the plant and spray it just like that. Within 24 to 48 hours, we're starting to get pictures. People are like, I don't know what's in this stuff, but my beans are already growing again. So you give it the things it needs. So if you have these photosynthetic inhibitors or amino acid synthesis inhibitors or plant growth regulators, you know, a little dicamba, a little 2,4-D in the wrong something. If you do too much of that, it'll kill these beans. But I'm just saying, if they're slowing down or you see them stop, don't sit there and wonder what to do. Some of these products are very inexpensive that we can go out here and fix. And all we got to do is just turn on the sugar and amino acid machines. And we can do that with some very, very simple products. I'll show you a little bit of this. How do we mitigate it? Well, we have to supplement the food, not the nutrients. All the nutrients in the world aren't going to fix this, because this is a food shortage. This is words of life, amino acids, sugars, proteins, enzymes. We put food first and foremost in there so that plant recognizes its food machine is going to be restored, because it's not doing a very good job of making its own food at this point. It's just sitting still. Time is of the essence. The sooner the fix goes, the better. When I tell you that you can actually go out here and spend $8, $12, $16 an acre, and you can make 20 to 25 bushels, that's not peanuts, boys. That's real. And you know, if I told people, oh, 4 to 5 bushels, they'd buy it all day long. When I tell them 20 to 25, they think, you know, I'm wasting my breath. If you do it right away, when you understand this is exactly what we're talking about. We're not talking about small numbers here. You can get back lost days of GDUs if you get on it quickly. Now, if you wait 2 to 3 weeks to wait till these plants look like they're getting close to growing, then you put it on, you still get some value, but let's face it, the benefit is not going to be nearly as good. So it's not nutrients, it's sugars, amino acids, and protein. It's food. It's the words of life. It's food. Sometimes you get too much stress. All you've got really is going on is ethylene production. Plants shut down, they start making ethylene. They say it's too hot, it's too dry. I'm going to go dormant. I'm going to turn on my ethylene machine. When they do that, they stop root production. This silly picture here that's way too complicated to understand is just something simple that we said, if we understand what ethylene production does, we know that if plants have the byproducts of ethylene production, when they've gone through this, and all of a sudden the plant comes back to normal and says, oh, I think we're done with the stress, and it makes a few things. All we do is we look and say, what is that few things you make? And the minute the stress is starting, we spray these things on there, these byproducts or after products of ethylene production. The plant says, oh, I guess I must have already been through the stress. It doesn't pay any attention to the stress, and it goes right on through it. And if it's ethylene, it's shutting down roots and telling the plant, get out of this, finish the reproduction. It's time to finish. That's what when we make tomatoes red or bananas yellow. That's how they make these things ripen. It's a ripening hormone. So ethylene is telling the plant, ripen, make the maturity earlier, get out of this, go home. We're shutting that all down and saying, spray this stuff. And when we do that, we take the stress off the plant, and the plant goes on magically ahead through the stress and doesn't fight the surroundings. And if we actually put sugars, energy in with this, we tell it, don't pay any attention to the stress. By the way, here's some extra energy. Enjoy yourself for a day or two. You go out and look the next day, and all of a sudden you dig up plants and you got brand new white roots growing on the plant like crazy. And everybody else is sitting there fighting the stress. And you think that doesn't make a difference? It makes a huge difference. If you've been told put on 4 or 5 applications of a fungicide because of the ethylene inhibition, don't pay any attention to that. That's dangerous. It's silly. It's going to wipe out fungicide activity for us forever if we continue to do this. These products can be, made available for $3 an acre, and you can do them multiple times. Most people, when they understand it, they'll put it on multiple times. If it's too cold and wet or too hot and dry, they're putting it on with any pass they're making, always just to keep this plant stress-free. Recovery after crop energy. So we put a little ethylene inhibition in here to make sure that this plant is not sitting here suffering. And then we go in here and we put in something like SG Relief, if it's by itself, 4 ounces to the acre. If we put in Shift, which is a combination of sugars and organic acids for energy, as well as a little bit of micronutrients, all of a sudden the plant comes to life. It's like, wow, I can now make from amino acids I can make my proteins and I can make my enzymes, and I have the micronutrients to make the enzymes work. Lo and behold, magic starts to happen. If you need nitrogen, Inforce is an amino acid nitrogen. It's already in the form of amino acids. Spray it on there, the plant just absorbs it. It's like, wow, I just got an influx of amino acids. Just like that, it's off to the races. SG Expand, it's a kelp-based product that actually will bring in certain types of plant growth regulators. If you want something to flower or branch, or if you want extra roots, you can put these things right into these products, and you've already told the plant, look, here's some sugar, here's some amino acids, and by the way, I want you to start branching or flowering tomorrow. And you've given it all the direction it needs and the energy to do so. You go out tomorrow, it's like, where do these brand new roots come from? Or where do these brand new flowers come from? Or, you know, a couple, 3 days down the line, this branch is popping already. That's because you told the plant what you wanted to do and you provided the ability to do it. Take that and add in extra nutrients of NPK, micronutrients, plant protectants, marry it all together. That's what SG Advance is at the bottom. If you want to, you could actually take SG Advance and throw in either a little bit of Inforce or some Shift along with it, and you'd get all these other things along with it. So if you want one thing that's simple, straightforward, boom, SG Advance at a half a gallon to the acre is your product. How about finishing this thing up? Nitrogen in the right form is huge. Nitrogen is not nitrogen, even though we've been told this for years. The more nitrogen, and it doesn't matter, just get it out here. That's a line of garbage this long. We've known for years that nitrate nitrogen is what we would call, let's say, male nitrogen, and it causes plants to be big and full and pretty and green, and that's what makes plants big. But nitrate nitrogen almost does entirely nothing to program reproduction. That's the job of ammonium or amine or organic nitrogen forms. That's what programs plants to reproduce. We know that when we feed different forms of nitrogen, the soil reacts different. If you have a soil that's very alkaline, way above pH 7, and you use urea or nitrate that turns the urea turning to nitrate, the coloration that you see in the roots here is just a pH reactant colorant that reacts to different pHs. The pH, when you use too much nitrate, is going to go through the roof. It's going to go way up into the 9s around those roots. If you use ammonium nitrogen or like ammonium sulfate nitrogen or even anhydrous, the pH around the roots is going to be very acidic. Now, if you understand that and the pH is very acidic around those roots, it's dissolving the metals all around those roots. When you use ammonium forms of nitrogen, you get so much more back from the soil as a result. It's strange how things happen. We've done this out in California for years where people didn't understand it. If you throw urea on a soil out there at pH 9, it turns green for a few days and it goes back to a funky color. And it's like, oh, that fertilizer is no good. Use ammonium sulfate or ammonium forms of nitrogen, it'll turn green, stay green for weeks because of all these other things. There's all kinds of other things associated with it. You look down through there. Acidic rhizosphere suppresses many soil-borne diseases. Ammonium nitrogen is preferable for amino acid formation. Nitrate won't do that for you. Shifts in ecology. If you give too much nitrate, you also feed root rots. They love the root rots. And so you'll feed way too much nitrate, you'll get that problem. Nitrogen in the right form, I just kind of went through. So this is kind of a highlight of that. But only the amine forms of nitrogen is going to make and fill your seeds. The process requires the plant to expend energy when we put this nitrogen in there. Nitrogen doesn't go in and immediately move. It's got to be attached to something. So depending on what form it is, it may take a lot more of attachments. So the process leaves less energy or sugar reserves for the plant to perform its functions when we do this. Now, if we do it as an organic form or amino acid form, amino acids, think about that as a sugar with nitrogen married onto it. So if the plant wants a little bit of nitrogen, it cleaves off the nitrogen, what's left behind? Energy. And the plant loves the energy, and it tells the cell, it's like, look at all this extra energy. So it gets its nitrogen and it keeps building things at the same time. This is why amino acid nitrogen is one of the most efficient forms, and that's one of the organic forms that the plants have learned to live on for thousands of years. This process, if we want to take nitrate and turn it back into ammonium, it's possible. There's enzymes in plants that do that. Soybeans have a lot of it. Corn has a very minimal amount. It stops making it when it's about this tall. So that means as it gets bigger and bigger, that concentration goes down. It's called nitrate reductase. And that nitrate reductase is present in kelp, And it's present in certain other varieties of corn in higher concentrations than others. You'll see the new short corns are loaded with that stuff. And you're going to find that when you want the nitrate reductase to work, if you remember back, I said molybdenum is one of the key micronutrient cofactors that sets on the end. So you got to have some moly around to make it work. And when we haven't used moly for years and years and years, lo and behold, that's a problem. Well, guess what? The boron we sell already comes with moly. So if you're using our boron in conjunction with all these things, you're going to get some moly at the same time. Intervene. When we take kelp-based products and put fulvic energy with it, the kelp has nitrate reductase. And so when we are using this to stabilize our nitrogen, ironically, carbon and nitrogen, you've heard of the carbon to nitrogen ratio. If we have lots of nitrogen in the soil, the first thing microbes do is like, look at all this nitrogen, it's way too high in soil concentration, get rid of it. Change it to nitrate, move it away, wash it away. If, however, you provide a food source for those microbes, when they see the nitrogen, they don't do that. They go in there and eat the carbon and the nitrogen, and they make more bodies. And so they make zillions and zillions and zillions of microbes, and that stabilizes nutrients of all kinds and stabilizes nitrogen as an amino acid form for weeks, improves yield production, dry matter, test weight on corn, and also soybeans. So we use these products and intervene either in the furrow or in a 2x2 application, or even sprayed, a little bit on the surface if you want to. We do that. The boron that we have also has moly in it. So we can use boron, 8% boron with moly in it, and accomplish some good things with the nitrogen manufacturing and the nitrate reductase. If you have more of that enzyme and you need moly, just like that, everything's more efficient. Because people have asked us for years, why does your boron do something different? Because it's got moly in there to support nitrate reductase action. Wow. SG balance, or SG elements with the balance form. Again, we go back to all those different micronutrients. We make those micronutrients available for that plant to make sure that all of these other systems function properly. So we can actually foliar feed them, put them in the soil, put them into wide drops, put them into multiple places, and with nitrogen efficiency, finish out the season in a very, very high productive scenario. Promoting crop sugar production, we have products like Advance, I mentioned before. It's got a multifaceted foliar opportunity with all kinds of stuff in it. This has been one of the most popular products for years, and there have been knockoffs when people try to make it cheaper. If you don't make it this way, it's very, very difficult to make it to work because it's got chelates. If you use sulfates, you can make a mess in your tanks. There's all kinds of things that people try to do to cheapen it. But trust me, there's no need to cheapen this product. It's a very, very effective, cost-effective product, and it works very, very well if you know what you're doing with it. Shift, which we talked about before, the sugars in organic production, organic acids, increases the sugar production. It also pushes the growth of the microbes. So as a foliar, even on the surface with microbe production on the surface, if you have a plant that's covered with biology, microbiology like bacteria, when a fungal spore lands on it, if it's not sitting on the surface of a leaf, if it's sitting on a bunch of microbes, it doesn't recognize the surface of a leaf, it won't even germinate. So where guys are using bacterial biology on their foliar applications, they're finding they don't have to have as much fungicide. The boron and the micronutrients we talked about just a bit before, but boron is necessary to regulate sugar flow. That's why you have to be careful. Get too much boron, it'll blow the plant apart. All the cells will blow up. That's no surprise, but we know how to manage that. We've done it successfully for years. And then we talked about, of course, the SG relief. So early and available high quality phosphate, that makes it work. Early and available micronutrient nutrition is very, very important. Early and sustained active microbiology sustains the release of nutrients from the soil. It doesn't have to be mutually exclusive. You don't have to rely 100% on God to water the world. You have to figure out that if we use some of these in conjunction with the system, they're going to be more efficient. We get the sugar machine up and running successfully, making sure it's not shutting down. We keep the sugar machine running at a maximum rate. The other thing that you're going to need to know is we've changed nitrogen and nitrogen sustainability for the plants. We are using way, way less nitrogen in these systems when we use Intervene and products like this to stabilize nitrogen. As you get into pollination and everything thereafter, right up to pollination and after, you only want ammonium nitrogen. Nitrate won't do anything for you. If you've done any late season stock nitrate tests, you'll know this. You only need about 2,500 to 3,000 parts per million. We have guys reporting back 15 to 25,000 parts per million. We have cut the total units of nitrogen people use to grow the same or higher crops. If you're using boatloads of 32 or 28% in wide drop or really, really late season applications around pollination, you need to consider going back to a 50-50 blend at the very least, or a 75% amthio, 25%, 28 or 32, because nitrate at that point, when it goes into the plant, does nothing except screw up the system. Even if you've been counting those in units as nitrate, you shouldn't be counting them. They're not doing anything for you. They go into the plant and they sit in the bottom third of the stalk. They never go anywhere until they can get either nitrate reductase to change them. And if they never do, they sit there. And at the end of the year, when you harvest that corn and those stalks begin to either lay down or open up or bust up and the nitrates come out and they're all sitting at the surface, guess what nitrate does to soybeans? It tells it not to nodulate. So those of you who are getting nice, big, pretty vines may actually be suffering from nitrate poisoning in soybeans, because nitrate will keep the plants from nodulating. And as you get nitrate down deep in the soil late in the season, if you get only moisture down the bottom and you got all nitrates, you got pretty green plants and they're just not yielding, it's because we got too much nitrate in the system. That's a whole nother seminar, but trust me, until you begin to grasp some of these things and look at the big picture of agronomy, missing yield has been showing up for people who've started practicing these things. They don't know why, and they'll keep telling me, you've got me on something I don't understand, but we're going to keep doing this. Because this year, when some guys shouldn't have even had corn, they had less total units of nitrogen. They told me they got more corn than they've ever seen, and their test weight was higher than they've ever had it, and it didn't rain for a hoot the whole season. Part of that was because they've been changing their nitrogen management system. That is trying to help you understand, and trust me, I'm sure your head's hurt. Don't try to memorize all this stuff. You can go back and watch it many, many times. That's not the objective. The objective is to help you understand that there's a lot going on behind the scenes that has not been explained to you. And it's not because people don't want to explain it. They've been told that you don't care. Now, that might have been true 25 plus years ago. That's not true today. Being familiar with things and understanding how systems work, that's what agriculture has always been. And you all know that efficiency is where you make money. So understanding systems and how they work together is going to make you money. And so SummitGold, through the years, as we've worked in conjunction even with my business with SP&C Corp and SummitGold, we have married these ideas together. And if we were causing farms to falter this day and age, you could go to the internet and find the list of people who are all disgruntled and upset and broke, and they can't stand it because they didn't put on any fertilizer. And this is not an anti-fertilizer discussion. For goodness sakes, we sell it. We just help them understand that until things get right, there's no need to spend excessive amounts of money on any given certain set of nutrients. Balance it out and then watch what happens. And then you can begin to move everything up little by little, and things get marvelously better. Until that point, don't get carried away trying to spend yourself into oblivion on dry fertilizer. Now, unless you're going to buy dry micronutrients, that's not a bad idea in conjunction with some macronutrients. But it's a philosophy that's built in science. It's not built in some kooky idea somewhere that somebody thought they understood all this stuff off to the right side and said, don't pay any attention to what these people are telling you. It's ridiculous. No, it's a marriage of all the things we've seen through 50 to 60 years of being around crops ourselves. And there's a lot of consistency. So when you understand that the soil is designed to feed the plant, and the stuff that we put on the plant makes more food to feed the soil, the reason is we're feeding that biology, the living organisms that are there in the presence of dead soil. I'm talking about just the silts, sand, silt, and clay, that releases the elements. The microbes receive the signals. They tell the plant, we're here. We can release these nutrients for you. You send us sugars and proteins and amino acids. We'll build our babies, and we'll give you a great opportunity to thrive. And that's exactly what they do. That's SummitGold in a nutshell. And I'll go ahead and, because I've gone over a little bit here, it's no surprise with me. This could go on for days. I'll turn it back over to Jared and Bruce and let them finish up. And I think if there's any questions, I don't know if there's questions in here that I need to answer or not, Jared, but if there are, well, I'll go ahead and answer them. If not, well, I'll let you finish up here.
Yeah, thanks, Dan. Yeah, I haven't seen any questions in the chat box. Bruce can pop on here if he's able to show his video and unmute himself, just see if he had any come in. But yeah, appreciate everything you shared, Dan. I mean, it's all really good things. And I'm sure some of the guys listening probably picked up a few new things. If you guys have any questions, I mean, pop in the chat thing or maybe drop Bruce a text right now, but you can certainly follow up with him later. I didn't mention at the outset, but kind of what we're doing here, obviously we're a supplier of these nutritional products. We're partnering up with the Sullivans to try to offer that in that region that he works in. So obviously we really appreciate the opportunity to do so with the Sullivans and your time as well, to just make available to hear us out, hear what we're about. And I hope you see that kind of the way we approach it's a little different than maybe most others, if not all others, that if you've ever talked to anybody that does this kind of thing with biological and specialty nutrition, I think we approach it in a pretty unique way that makes a lot of sense when you take the time to think about it. So again, we really appreciate the time, Bruce, as well, and the opportunity to do so. I'll turn it over to you if you have any few closing words.
Yes, thank you again, everyone who participated in the meeting. If you do have any questions or want more information on the products, just send me a text, call me, whatever, and we'll work out an approach to that will help you. And like I said in the beginning, I like to view this as kind of like a holistic. It's a holistic approach to truly sustainable and profitable agriculture. And so again, thanks for participating in the meeting, and we'll sign off here now, and we'll be in touch with each of you. Thank you. And thanks, Jared and Dan and Greg, because Dan, can't thank you enough. I've always enjoyed every meeting I've sat in with you, and I always learn something new. So thank you so much.
Well, there's more stuff coming, Bruce, so hang tight.
There you go.
Thank you, Bruce. Appreciate it.
All right. Bye-bye.